All right, welcome back to Programming Through Mobile App Development. Today we're going to get into JavaScript programming finally. Hey, the programming part of the course is coming to fruition. Wonderful. Our agenda is what is JavaScript? So basically what it does and why we should learn it, right? And then writing JavaScript. So some fundamentals of programming, the tools of this particular trade, where to write it to make it work on your web pages and such. So yeah, let's get into it. What is JavaScript? And why should we be spending all this effort to learn it? Very first, I want to ground this really quick, right, before we dive into dissecting it. What is this thing for? What does JavaScript do for us in a general sense? So after your web page loads, JavaScript can do things like create new HTML objects or alter text. It can change CSS properties or classes of HTML objects. And essentially, it's used to create dynamic or interactive web pages, things that respond to the user's input rather than just being a static page, right? It can also run, logical programs. So logical things. We'll cover these in future lectures, but if statements and loops and functions and all these fundamental programming things that you do in every other programming language course, not programming language, but like all your intro to programming type stuff, that's the kind of things that it can also do, right? And then just tons of other things. It can do math for you. It can access other pages or other pieces of information from elsewhere. It can draw on a canvas. It can create the logic of a complete video game if you really want to do that here, right? So that's the foreground, right? This is to couch this all in why you would want to learn to use a programming language in this setting, right? Okay, so let's get into what exactly JavaScript is. JavaScript. I've heard about Java in CS12, right? CS212, right? We've discussed this previously, but JavaScript doesn't actually have any true relationship to Java, the programming language. The emphasis is really on the script part here. For a little background, JavaScript came about at a time when Java was sort of the growing, programming language de facto. It was hitting its stride, and it's still a powerhouse today. It's in the top 10 for sure, but that was back when it was first going. So all the accounts vary. Generally, it's accepted that it was just a nice way to co-brand. So if Java was popular at the time and we needed to name our new in-browser language, JavaScript is the name ascribed. But the thing to focus on here is the script part. So this is a nuance that I want to bring up. Scripting versus programming. It's sort of a subtle difference. So far, I've been always referring to JavaScript as the programming language, right, that we're going to use here. But there's a little bit of nuance. So pure programming languages, classically, are ones that have to be compiled, meaning you write the code, and then you run another script, another program on your code that turns it into like the really low-level, tight, executable file, so the program. Anytime you have run something with a .exe or .app at the end of it, those are usually compiled ahead of time to make sure that they are streamlined for your computer and run them as efficiently as possible, right? When you install something, you are typically installing not just some scripts that will be read and things will happen, but really a super condensed version of those things. Scripting, on the other hand, JavaScript is a scripting language, and scripts can happen a little bit more on the fly. There's no build step. You don't have to compile it down into a very specific piece of machine code for one computer. You can pretty much run scripts anywhere that there is an interpreter installed. So interpreters are the thing that sits there waiting to read lines of the programming language one at a time, and it just runs them, right? And so it's not streamlined like that, but it's super flexible and very portable. Like if your code in a scripting language runs on one system that has that scripting language installed, it should run on all of them, because it's really just a set of instructions. It's not trying to get compiled down into something really, really low level. So that is, which is it? Which is more important? Which is better? It doesn't super matter for us, right? It's all programming. It's all good. For our purposes, we're going to kind of be focusing on the simpler side of web development, right? We're not doing anything hugely complex in this course. This is really more of a theoretical difference than a practical one. And because you can build fully functional apps these days using purely scripting languages. There's even tools that you can use if you do want a compiled version of a scripted program. You can do that. That like exists now. So, but kind of more importantly, scripting and programming are about giving logical instructions to a system to define its behavior. They are the same in that regard. So just know this difference exists, and we'll move forward. So generally, a programming language in general, what does one of these languages actually do? So the fundamental thing is programming languages use logic to manipulate data. Okay, that's a little broad, but I think it's an accurate take, right? You are setting up series of instructions that will flow logically, and the result is to change and move and store and do things to data. So in this case, it sounds a little bit abstract, but recall that everything we've done so far in HTML and CSS are actually speaking that same language. Remember the DOM. So these languages set up the data inside of the DOM to make your web pages appear in a particular way. So this core idea is that programming languages define behavior by doing this. What should the computer be doing to this data over time, right? And then from there, you also define how your program will interact with the user. Here's a little flowchart just sort of to illustrate a logical series of steps, right? If your lamp doesn't work, you then proceed to this query, this question, which will have a yes or no answer, right? Is the lamp plugged in? If no, our result is to change the data of the world by plugging in the lamp. If the lamp is plugged in, okay, is the bulb burned out? If it is, replace the bulb. Otherwise, okay, no, the bulb is not burned out. We've done our two logical checks here. All right, so now we're going to have to send this thing in for repairs. The starting state is that the lamp doesn't work. We do a couple of checks to decide what to do from there. This is sort of a simple if statement. That's the concept. That's one of the many concepts, but it's a core concept of how we are using logic to decide on instructions, right? So I want to give a quick list to sort of brush across the surface of some programming concepts. We'll get to some of them in time. We'll get to some of them today. So some major concepts that we're going to cover going forward. Variables and data types. So what are the types of data you can mess with in these languages? Branching. So that's what we just did with the lamp. Choosing the next step at decision points. And, we'll cover all why that's useful and how to do it and everything. But another one is looping. So that sounds simple, but sometimes the most powerful thing a computer can do is do the same thing 10,000 times, because we're never going to do that. And being able to get a computer to do it is fantastic. Functions. So this is defining and naming bits of behavior that we want to write as instructions for use later, which is great. One of the core ideas is that you keep bundling things up into more and more useful function calls. And even more like that is objects, so object-oriented concepts. So grouping both data and behaviors into these meaningful chunks. And lastly, events, so actually reacting to things that happen, like when the user gives input to a page, that kind of stuff. Here's another flowchart. So this is a logical, I say flowchart, directed graph, diagram, whatever you want to. There are lots of colloquialisms that refer to this, but this demonstrates the flow of a logic of a guessing game. It's a guessing a number between 1 and 10 game. Okay, so at the start, we start. First thing that happens in the game is the system will tell the player about the game. The game will then internally pick some random number between 1 and 10. Okay, so it's going to... Now you think about this, it is holding on to some piece of information, right? Then, it's the player's turn. The player will pick a number. So now you have two pieces of information. We have the number that the game generated for the guessing game and the number that the player picked. Two different pieces of information. Now we can check, are these the same? If no, we output you're wrong. If yes, we output you're right. And then either way, we go to the next question, where we get another little piece of data from the user where we ask, do you want to play again? If no, the program exits and we're done playing the game. If yes, we go back and we perform a loop. We go back to the start and we keep doing this guessing game until we get bored because it's a stupid, boring game. But the fact is, you are able to define all of the components of that game here in this logical flow, right? That, at its core, is what you're trying to do in programming, right? But instead of a stupid guessing game like this, you might instead be trying to trying to create an experience for a user who is, interacting with your website, right? Oh my goodness. All these notifications. Okay, so let's talk JavaScript versus CSS and HTML. We are finally into programming proper, right? The difference between these three is all about how each of them interacts with the DOM. HTML sets up the structure of the data objects in that DOM, right? Remember the tree of how your paragraph is inside of the body, which is inside of the HTML object, all that, right? CSS defines the properties of those data objects in the DOM, so changing the colors and font sizes and everything. And then JavaScript defines the behavior of how your app will change parts of those data objects in the DOM, even after the page has loaded, right? So while HTML and CSS are this sort of upfront one-shot, JavaScript comes in and says, okay, now I can do anything as we continue to use this page. On top of that, though, you can do things outside of the DOM. You can do things in a purely sort of programming environment style, where you set up variables, change them, calculate things, run a whole script under the hood. It has nothing to do with what's visible, right? Import other packages. You can do all this stuff that other programming languages do, on top of being able to directly interface with the DOM. Here's another slide that I lifted from a website I found that is quite nice. Quick description. I'll just have it up here for a moment. You can look at it if you want. But it's a nice way to contrast these three. Okay. Now, here's an additional thing. Why JavaScript? Right? I mean, I could just jump into telling you how it works now, but I want to keep setting the stage as to, motivate you as to why this is such a good thing to learn. So it's a web dev course, of course. We gotta use JavaScript, but is it worthwhile outside of that? So yeah, it's aimed at web app development. Consider this article I found recently. It's from the Berkeley Coding blog, written this year. And they list JavaScript as the #1 in-demand language with some evidence to back the claim. They pulled in some information from surveys and all that kind of stuff. And up here we have, it stands as the most commonly used language in the world at 69.7% of developers surveyed in Stack Overflow's 2020 developer survey, followed by HTML and CSS, and then SQL, Python, and Java. And it's the most sought out programming by hiring managers. They have a whole PDF about that. So it's all for good reason, right? Every web page you've ever been to is using JavaScript, even if they didn't write it themselves. Remember that the engine, the language under the hood of your browser is also using JavaScript. So if you understand JavaScript, you understand things about how browsers work, or you at least begin to, right? So nearly every browser widget or tool or game that you've ever interacted with is written in this language. So don't think of this as some toy language just for making pretty little websites that you might never use. If you choose to pursue this as a skill, there's a market for it. So keep that in mind. This is not like a dead end. This is actually the very beginning of a long journey if you want it to be. Also, as a teacher and someone who's pretty familiar with cognition writ large, I've heard programming courses are notoriously hard for students, right? That's this next question. How hard is this? I heard the second level Java course is impossible for some people, all that kind of stuff. First is the hard news. Learning programming is difficult. You're spending a lot of time trying to force your brain to think in a new way. It's hyper logical. It's very precise. Oftentimes it's it's abstract and it's all like in logical concepts and stuff. But that's not just you, and that's not, just you and your other people you've taught. That's kind of everyone. I taught this stuff in undergrad as a tutor, right? And I tutored mathematicians who were brilliant, but they would get so frustrated with trying to learn programming that they would leave and decide it wasn't for them. Math that is so close in concept to it's all numbers under the hood of a computer, but they bailed because they decided screw this, it's not worth the effort. So the key, I believe, is to get a few basic insights to click into place. And then from there, it's all about practicing and exploring and trying new things in programming, right? Maybe even finding projects that get you interested in it. Now, the good news is that I think it's easier to get all those aha moments with a programming language like JavaScript for a few reasons. First, scripting takes less setup than a compiled language. JavaScript has an interpreter, and that's inherent in the fact that it's a scripting language, but the interpreter is a super useful tool. It is a way for you to just jump in and start writing stuff and see how it works immediately. And it's all really well grounded in all this effort, these pains we took to get into HTML and CSS first, right? If we want to see how data changes the things that we're interested in changing, this is the way to do it. So altogether, we get this more interactive, less setup-heavy environment for you to explore, make errors, and learn a whole lot just on your own, trying things and seeing how they change. Let's get into a few of these ideas just to sort of continue setting the stage. First, scripting languages have less setup, meaning it's less arcane, right? Consider the most basic program you would write in any language. Hello world, right? The idea of Hello World is to establish an input-output connection between you, the programmer, and the system you're programming in, right? You just ask it to say hi, and it does. That's like a fundamental, basic assignment in any programming language. In something sturdy, in a software engineering-focused language like Java, you're immediately confronted with about 12 undefined terms inside a nested coding structure that they say, hey, ignore all this and just type this and it will output hello world, congratulations. That's a lot. Public, class, my first class, public, static, void, main, string, brackets, args, system.out.println, hello world, we finally reach. In a scripting language like JavaScript, this is one line. Console.log, hello world. We are asking the system, just print out hello world. So obviously this is not the extent to how complex programming is, right? But to start off, we get to focus on sort of one thing at a time. What is outputting? Well, it is this, console.log, hello world. Next on the list of useful learning elements of this, interpreters are interactive inherently. You can try things out on a whim. So another excellent feature of JavaScript is that it's a language run through an interpreter, right? Essentially, this is a little prompt that sits there waiting for you to give it commands. The exact same commands you'll use in your scripts, right? You are learning to speak a language in terms of commands, and the interpreter is your shortest route to checking and using that. So this means whenever you need to try something, it's as simple as popping the interpreter up and check it out yourself. Did you forget how an array works? You can just make one and find out. You can poke around at it. Can you not remember what a certain function does? Well, you can call it. You can load your script and then call that function right there in the interpreter. the interpreter also remembers what you're done in a session. So let's say you load up a page and you start making some changes using the interpreter and you're correct. Like, oh, shoot, that worked. Okay, you can keep building on what you were just testing. So what all this means is that you're always no more than a few clicks away from being able to speak JavaScript to the interpreter, which means your practice loop is very tight. You can get feedback really quick, and feedback is the only way humans learn. And here, just for a taste, this is, me trying a bunch of random stuff in the JavaScript interpreter. This was me, okay, let me try to remember, again, literally, how does an array work? Well, I made an array, I started doing some stuff, and okay, it's returning things, and it's doing. We'll get into all this. I just wanted to demonstrate that this is how the interpreter sort of works. It just sits there, and you give it lines, and it's like, okay, I'll process each one at a time and show you the result. You can even use it as a quick and dirty calculator, which is kind of cool. Like if you just want to do some math right there in the interpreter, you got it. You always have a quick calculator available if you're on a web browser, now that you know that. We'll get some more of that later. Okay, so another element that I discussed up front there was programming is kind of inherently abstract, right? It's logic done on numbers and data, right? So it's like endlessly abstract. Great, I made a function to take two numbers and calculate a different, larger number. Cool, I guess. That just comes with the territory. That is how programming functions. It's fundamentally about transforming information, applying logical processes, often in the form of mathematics, to data, and then numbers doing stuff to other numbers. Yay, cool. Okay. The key benefit of web dev is that it's all semantically grounded in HTML and CSS. These things are more concrete for us, right? As we've already seen, the primary data we're working with in all of this are the data objects from the HTML in our DOM. And we already know that changing those objects' properties has huge visual impacts, right? So these HTML elements and their CSS properties that we've already covered here form the building blocks of this sandbox, right? And JavaScript is how you mess around in that sandbox. Meaning, everything you learn to do in the logic of JavaScript is geared towards making meaningful changes to parts of your web page, which is inherently more interesting than, abstract numbers for their own sake, but it also helps keep everything grounded as you learn, right? So as you figure out what each of these different kinds of logic are for, you'll also have memories of, oh, right, that moved the object around the screen, or that changed the color, or whatever. So, and again, remember that feedback is key. So visual feedback, awesome. Awesome to have right here in front of you. Other benefits, it's inherently object-oriented, which is a more intuitive way to think about programming in general, but it takes you a while to get there in most of these languages because it's not front foremost, right? And it makes a certain kind of sense. You're trying to build up to objects. But here, we kind of started with them. So that's just a general benefit. You'll see why gradually, I think, as we continue. And it's also a huge sandbox, like I said, of available elements and properties, right? It's a little playful. Guaranteed at some point, you'll get curious. Wait, if I can do that to this kind of object or property, what if I try this kind of change or whatever, right? Those questions will sort of naturally flow from just the fact that you got a whole bunch of stuff available to mess around with. So here's just an illustration of the abstract idea, right? So this is using looping logic to continuously change just a number value on its own, which is kind of cool, right? Being able to change a number over time repeatedly, that's interesting. But this would be using looping logic to continuously change the numerical color values of an element on your page. One of these is a little bit more fun and curious and interesting, and it sort of opens the door to, oh, I could do a lot of cool stuff if I knew how to do that, right? It's the same fundamental process. You are changing a number repeatedly, but in one case, it creates a rainbow effect, and the other, it's a number changes. Okay, so This has been what and why is JavaScript. JavaScript is a programming language, specifically a scripting language designed to work in web browsers and interact with the DOM, as you have initially set it up with HTML and CSS. It's fully featured. It allows you to use all the fundamental programming concepts any other language does. It's one of the most in-demand languages in the world right now, not just some fun toy. And it has a lot of benefits for learning programming concepts. It keeps all the abstract logic that is really inherent to programming. It keeps it all grounded in these building blocks that we've already learned a bunch about, HTML and CSS stuff. So that's the short of what this is and why we're here. Okay, now let's get into writing JavaScript. We'll cover some tools, where to use them, and some basic programming concepts. First, some fundamental programming concepts that we'll need to do any kind of programming, but the ones that we'll first encounter here in JavaScript. So let's say if we want our page to do something after it's loaded using JavaScript, what exactly are those things that we can do? To start, let's just talk about the very basics of all programming. So we'll live in that abstract space for now, and then we can ground it later. First, data types. What kind of data is even available? Next, operators, like in math. So like addition, subtraction, that kind of stuff. Variables, which is a little different than in math. If you're thinking about algebra, it's not the same flavor as algebra. We'll talk about it. Functions, which we covered briefly before, the idea of kind of bundling up instructions into a reusable form, and objects, which is that, bundling up instructions and data into reusable forms. Okay, let's get started with data types. And there are two sort of categories of data types. Primitive data types, which are like the sort of fundamental, most basic units, and more complex data types. We'll start with the primitives. So these are the ones that are the simplest and most straightforward. So in order of complexity, we have Boolean data. Boolean, if you have not heard of that before, is binary. It's a single bit of information. One or zero, on or off, true or false, yes or no. A single determinant. There are exactly two values that exist for this in JavaScript. It's either a true or a false, and those are case sensitive, those are exact, right? This is the most absolute most fundamental piece of information you can have. Usually you would use a Boolean to sort of determine a switch, right? So if in the previous example with the lamp, right, is the lamp plugged in? The answer to is the lamp plugged in is a Boolean yes or no, a true or false, right? So then you would take action based on that. Next data type available is numbers. These are our old friends numbers. They're either whole integers or decimals. They're all considered the same thing roughly in JavaScript. You don't have to play too careful with that. But it is important to know the difference. Integers are whole numbers and decimals are the rest, right? The last primitive in JavaScript it's not always a primitive in every language, but it is considered one of the most fundamental types of information in JavaScript, and that is the string. You might be used to thinking of this as words, letters, sentences, etc. Everything on this page is technically a string. Strings are sequences of letters denoted by either single or double quotes. So you put double quotes around something, that is the delimiter. If you put single quotes around something, and if you mix and match them, you get a little funky. So each one of these is a single string. The letter A on its own is a string. Single quote sandwich, that's a string. Full quoting, like a whole sentence here, that is also a string, right? It's everything between the double quotes. Google with a question mark, single quotes, right? And those are the main three. So think of these as a single unit of information available to you. If you want to know some stuff about, for example, one of the all of the properties we've talked about in CSS so far, most of them are one of these, right? We have true and false, some numerical value, or a string. Some of them are more complex, right? So pixels, the px notation, that is, so 10 px padding, right? That is technically a string, but it later gets separated out into a number, 10, and px is just the unit, right? There are two more primitive data types I want to make a note of just for completeness here on this slide. We'll cover them in the future as they become relevant, but these values are undefined, which is exactly one value, and that's for when a variable does not yet have a value. So you've got a space for a variable, but there's nothing in it. That is a state called undefined. Null is for when you want to intentionally set no value into a variable. That can become useful when your logic is based on numbers, but you don't want to have a zero in there, right? We'll talk in the future. Okay, so these are the primitive data types. These are the most fundamental pieces of data that you can do things with. Okay, now let's get into operators. Similar to math, this is the basic way you can combine information to make new information, right? There's lots of operators that you use you join two pieces of information, two raw pieces of data, right? Most of these are the fundamental ones are mathematical, right? So addition is the plus symbol, subtraction is minus, or the dash, multiplication is the asterisk star, and division is the forward slash, meaning, so you see on the right hand here, 1 plus 5 is an operation, right? The result of that operation is 6. 7 divided by 2, 3.5. 100 times 100, 10,000, right? So a statement that joins two numbers with the math operator will return the result. But there's something to know about these simple operators is that they can be context sensitive. So what if I did addition for two strings, what would that mean, without scanning ahead on the right? It wouldn't really mean anything. Mathematically, there's no operation to add two strings together. That doesn't really make sense mathematically. So, but in JavaScript, and a few other languages are similar to this, adding, in quotes, two strings together is a concatenation operation, meaning you shove them together end to end to create a new string. So the example on the right side here, A, the string, plus B, the string, equals the string AB. Daryl plus space, a string with a single space in it, plus barrel is the name Daryl Barrel. Yay. ABBA plus CABA. And that's a minor thing. It went back all the way, huh? I'll leave this one in. Usually I edit just kind of junk out, but it's important to know I'm human. So, the last bit here, there are some oddities. So if you decide to try and add a string to a raw number, it just converts the number to a string and does the concatenation. I think that's sort of it's a precedence thing. It's a catch-all. If the system isn't quite sure what to do, it'll default to the most general solution, which anything can become a string easily. So is this making sense? Is this, we've got some simple math operations where we take two pieces of information and combine them into something new. And we've got the same going on for string concatenation. We can take two strings and shove them together. Neat. There's one more operator that will become very useful in the moment, and that is the assignment operator, the equals sign, which means the thing on the left is going to receive the value of the thing on the right. But what does it mean to receive a value? Okay, we're going to get into variables now. And this one, some of you've already got it. You know what I mean already. But this one can be a real stumbling block. I think people forget that the simple stuff is sometimes hard to grasp. So let's go through it careful. The idea of a variable is essentially you're just storing some kind of information in a labeled bucket. So a variable it's a label, so some name that you create on the fly when you're writing the code that points to some piece of data. It is stored somewhere. So you can use a variable to keep track of something for later. later in your code, you can call that variable name and get whatever is inside of it. So here's a quick example. This is how you would define a variable called name, and the assignment operator, and then Daryl is the string that we want to put in that. What we've just done is we've defined a variable called name and given it the string Daryl. So now, whenever it's relevant later in your code, you can ask for that, for the name that was assigned to this variable. It might not be clear like why that's useful or why that's powerful yet, but just try and get your head around this specific piece of the puzzle. Okay, and here's an example. We'll just dissect the terms here. When you read this, I'm trying to turn it into English for you, right? What this statement in JavaScript says is, I'm declaring a variable named X and putting something in it, which is the number value 10. Also note that little caret is not part of the instructions. That's just how interpreters often indicate, like, hey, your turn. And the return will be the opposite direction. So this is the syntax. This is one sentence in the language that says, hey, hang on to the number 10 in a bucket called X, right? Quick examples on the side here. So here are some examples of assigning variables. Var X equals 10, var Y equals 150, var Z equals the string dog, whatever we want. We can put values into different labeled buckets. Then when it comes time to use them somehow or another, we can do the same thing we did with the operators, right? You can use operators on variables because the variables represent pieces of data. So if I call X plus Y, what happens? We get the value 160. If I call X minus Y, what happens? We get the number value negative 140, right? I hope this demonstrates the sort of super basics here, right? We are able to hang on to information in the form of a variable, right? Things that we are allowed to name. Another piece of this that's really useful is that you can change variables, right? So altering the data without altering the structure of the rest of your code. So this is one of the best features, right? They are a stable location for information. So all of your code might refer to the same X variable. Everything you do might refer to that same variable. But then you can change what's inside X to change how your code works, right? Or rather, maybe not how it works, but change the result of running your code, right? So you can go into an existing variable and alter its value. From then on, whatever other lines might you be using that variable will do so with a different value. That's not, again, these are the super fundamental building blocks. It's not going to be super exciting. But when you combine this into more complex code, that means that you can make tiny changes that affect things quite a lot. Think about those CSS properties, right? We change one value of a background color and suddenly the entire website looks different to our eyes, right? We change it from white to black or whatever, the string. Okay, so on the right-hand side here, here's another example, quick rundown through the interpreter. So var X equals 100, var Y equals 25. Those are assignment statements. When you do an assignment like this, when you create a new variable and store something in it, they actually don't return anything. They return undefined, which is great. Just know that that's a thing. Okay, so now that I've stored two variables, I've got X is 100 and Y is 25. If I do X/4, so that is the statement divide X by Y, I get 4. Or sorry, X/Y, huh? I skipped ahead to the answer. Now I'm going to change Y to 23. Note that you don't have to declare the variable again. You've already declared it. It exists. So I can just say Y gets the value 23. And now when I run that same exact X divided by Y, we get a wildly different number. We get 100 divided by 23, which is a super irrational, not rounded number. That, I hope, demonstrates the idea that changing a variable is super useful, right? Having the capacity to switch little bits of the data around without changing how that data is used. Mwah, chef's kiss. Okay, so let's do a quick syntax recap and discuss a little bit about the idea of tokens. So you might call, and in fact many do, any individual chunk of text in a line of code is a token, right? So primitive data values, operators, and variables, these are all tokens. Numbers are just the numbers on their own. So just the digits 10, 20, 30, etc. Strings are text, but denoted by the quotation marks specifically, as contrasted to variables, which are text on its own. X, Y, name, date, etc. So text that you encounter in the code without quotes around it is a variable. It's a reference to something. Whereas letters that you find with quotes around it is meant to be a string. It's a piece of data. So letters without quotes is a reference. Letters with quotes is data. Make sense? I hope. I know you can't respond back. This is a recording, but I hope that those checks will still be useful for you. Okay, and then operators are specific symbols kind of on their own, right? We've got the plus, the minus, the asterisk, the slash, the equal sign. There are lots more, but these are all stand-ins for specific mathematical functions, or in the case of the equal sign, the equation, or the assignment function. Oh, and we've also seen one special keyword that helps instruct the system about what we're actually doing. These happen pretty frequently in code, but they're a different type on their own. So in this case, the word var, the symbol var, VAR, means I'm about to declare a variable. I'm about to assign a new variable. This just helps the system make sure, I got to do the basics to get set up to catch numbers. Thank you. Whereas if you do it without it, it kind of works, but I wouldn't advise it. So stick with var. So at this point, you should be able to translate the following JavaScript instructions into meaningful human language. For example, 10 plus 20 means return the value of the number 10 added to the number 20. The string cappy, the plus operator, the string bara, should say to you, return the concatenation of the two strings cappy and bara. Okay, here's a new one. We're combining things a little more now. Var x equals 10 plus 1000. Okay, so define a new variable x and give it the value of 10 added to 1000. So x should contain, in this case, 10,010. Okay. Now, let's move into functions. Combining instructions into their own named functions. So similar to what we just did with putting data into named variables, we can put whole lines of code into named functions. So yeah, we can compute some math and smush words together. Cool. How do we do something more interesting with that? So you can give a name to more than just data. As I said, you can also give a name to groups of instructions you want to call later. So you can recognize a function, compared to the tokens we were just talking about. A functions token is going to be when there's a parenthesis after the names. So in this case, bad plus, you see it on the right-hand side. We'll talk about that right now. The function bad plus, look in the upper left of the examples here. Function bad plus, open parens, a comma b, and then curly braces. That sort of defines the what I'm actually going to do. The only thing I do in this function is I return the value a plus b. So all this is me creating another way to do addition that it already existed, but I can do it in a function. Yay. And you see I do it right below. I call bad plus on the number 1 and 2, and I get 3. I call bad plus on the number 5 and 5, and I get 10. Joy. I reinvented the wheel. Okay, but back to the left-hand side. We'll cover the rest of the examples in a minute. So bad plus tells the system, hey, with parentheses at the end of it, and normally you would give it the arguments it needs too. I'm just making the distinction here. Anytime you see parens after a name, that means it's a function. That means the system is going to try and run a function named bad plus, something that is defined somewhere that can be used and execute code. Bad plus with no parentheses tells the system, hey, try and find a data variable called bad plus and give me what's inside. These are two different things. I hope that makes sense. Again, we haven't covered any of these ideas in depth and you haven't had your hands on it yet, but I'm hoping this is coming together. So we're going to cover all that later more, but for now, just be aware that creating functions is a main feature of all programming languages that are modern ones. The ability to make functions is very good. Some more examples right here you should pay attention to. So on the upper right, we have the function nameString, which takes one variable called first for the duration of this function. It's called first, and one called last, and that will return first, which we are assuming at this point is a string, plus the string space and plus the last, meaning if I give this function a first name and a last name, it's going to return a normal looking name, a full name, John space Doe. The next function down is going to do almost the same thing. We still give it first and last name, but I'm going to arrange them differently. I'm going to return last name first plus this little string. This little string is a comma and a space inside the quotes, and then I'm going to add to the end of that the first name, right? So last name, comma, space, first name. Now when we call string name on John Doe, we get Doe, comma, John. Now, again, are those exciting? No, not even a little bit. But I'm trying to demonstrate that we have the ability to take information into a function, do different things to it. We can take the same information to two different functions and it'll arrange it differently. It'll do different transformations on it. And this last one, I just wanted to throw one in that I actually use kind of constantly. I have to define this function a lot because it's not always right there. If you want to find the distance between 2 points, say, I have a point somewhere on a screen and I want to know how far away is this point from some other point, by a straight line, you can do that calculation. Recall from old algebra stuff, right? A squared plus B squared equals C squared. The distances are A is sort of the lateral distance and B is the vertical distance. And then you can square those, add them together and square root it to get C. And that's exactly what the function is that I define when I make this constantly is I take 2 points, x1 and y1, x2 and y2. I take their distances between those points. I square each of them, square root the whole thing, and return it. And I demonstrate here that those are, in fact, the square root of 2 is the distance between 0, 0, and 1, 1. And the distance between 0, 0, and 3, 4 is 5. So, blah, blah, blah. You can come back to that someday when you're curious about, like, oh, yeah, that function he defined. But otherwise, that's the idea. Okay, composite data types. These are a bit more advanced. So these are more maybe complex is a better way to put it. That's the simple stuff. So let's get more involved. Composite data types are data values that may themselves have their own data values. The first one is arrays. So it's a list of other data values, and it can be any length, and you can mix and match types, whatever. It's very loosey-goosey in JavaScript. Here's an array of the numbers 1 through 5. Here's an array of the letters A, B, C, and D as strings. Here's an array with John the string, Doe the string, 37 the number, and false the Boolean, right? You can put whatever kind of stuff you want to inside of an array. Objects, on the other hand, are collections of both other values and also whole functions. You can do whole operations within an object. So the idea of an object is you're usually grouping things into chunks that sort of make sense as a unit rather than just having random variables strewn all around. and we've seen them before. We'll get to that in a minute. So quick on arrays. So this is super useful if you want to store a lot of things, a lot of the same information in one bucket, right? So yeah. You might want to keep track of several pieces of information that you either, want to send somewhere together to be processed in some way, or you may want to perform the same operation on lots of data at once. Or maybe they're all just kind of the same kind and you want to store them all in one place, right? And again, they aren't picky. You can store whatever you want in an array. To access values in an array, you use an index, the index notation, which is a number inside of a bracket, starting from 0. This is important. So array name, whatever we've called it, I call this sub-0, so as in like almost like subscript in math. But so array name sub-0 that would access the very first value. We start from 0 because it's the lowest number. That's just how that works in computing. Array name sub-1 accesses the second value, and so on. This here is this example over here shows I've defined a variable called colors, and it has a bunch of strings of different colors. If I want to look at that variable, if I just call colors, it returns the whole array. It shows me the whole thing again. If I call colors sub-0, I just get red. If I call colors sub-3, I get yellow. If I call colors sub-4, which it would, remember, we're off by 1, that would be outside of it. That comes back undefined. Okay, so that's arrays. This is a sort of a simple way of grouping information together that you don't want to necessarily go as far as an object. Arrays have their own advantages that we'll get into at some point. But carrying on, objects. Okay, so this is how we intuitively group data and functionality. Objects are collections of simpler variables, in this case called properties. Ooh, that should be familiar. And functions, which in this case you call them methods. So the variables of an object are properties, and the functions of an object are methods. That's just a terminology thing for the most part. You don't have to worry about it. The idea holds, though. Objects have data and functions. It's information and behaviors that go together. I say it intuitive because thinking of a single number variable all on its own is just sort of an abstract number. But thinking of a number as one feature of an object, for example, its height or width or weight or opacity or color, ringing some bells, that gives the variable some meaning, right? So all of the CSS properties we've edited so far are actually just properties of the HTML objects we've been creating. So HTML objects have lots of properties. Another one that is useful and interesting for us to edit and mess around with is the inner HTML property. It's the contents of the tag. So for a paragraph, its inner HTML is the text of that paragraph. Over here on the right side, we see, here's the HTML code. Hey, create this paragraph called Hello World. And in the browser window, we see Hello World. Great. The DOM object that it creates, right? It's a P element. It has the color property black by default. Its width is, in this case, 400 pixels by default. Its background color is white. Its height is 250. Its inner HTML is the string Hello World. So now, let's do an example. Here's a bunch of text. We can see it here. And we have one header with the ID, the big one. Here, and then again, the internal, here's a bunch of text. So now if I go and I grab that element out of the environment using this is a function that you'll get used to using. Document is the DOM essentially. And you're asking the DOM, hey, get element by ID. So find me the element that has the ID, the big one. Okay, it does. And it returns that object. Cool. So we can actually see the object is just dumped right out here into the console. Now, if I want to store that and do things to it, I can do that with a variable. So in this case, I've already run ahead, but so using a few simple lines here, I can say, hey, define a new variable x that's going to get the data object of this HTML object on the page. And then I say, hey, initially, x.innerHTML, what's in there? Well, it was what it was before. Here is a bunch of text. If I say x.innerHTML equals howdy, it changes. Now, if I look at x.style, it has a style object inside of it. So now if I change the style object's property background color to red, ta-da, I have in the console, in the code over here, I have altered the properties of the HTML object in the browser. So this is pretty powerful. I hope you're starting to recognize this is some powerful stuff. You sort of have access to everything when you're in JavaScript. So again, to that point, the JavaScript console has essentially everything. It can alter CSS, it can create whole new HTML element objects, it can delete the entire page and rebuild it from nothing if it wants. So here's a quick overview of how this happens. So the web browser pops up, and let's say you've loaded a web page, right? The first thing that happens is the HTML interpreter comes in and it constructs all of the objects, right? We have the DOM. The DOM has the HTML body and the body, and it has a header called hello and a paragraph called world. Cool, not called, but with the text. And then the CSS interpreter comes in and says, okay, HTML thing has done its job. It's built the page. Now I'm going to come in and change some properties of those elements. Okay, cool. The paragraph's smaller. I mean, the header bold, change the colors, blah, blah, blah. The JavaScript interpreter has access to everything. It can do stuff outside of the browser. It can do stuff inside the DOM. It can do stuff inside every single little element that you've created. It can do everything that the HTML and CSS interpreters did. That's power. That is us kind of blowing the doors off of this static web page stuff we've been doing so far. Okay. Some useful objects that already exist when you load up a browser that you should know about. And this is a nice little reference page. So one object that we've already touched on is the console object. Essentially, it's just you can take control of the console in some ways. The simplest way we do that is we log things to it. If I want to print something out to the console, I can just say console.log whatever string I want or whatever number I want or whatever. So it lets us spit data out into the log. This can actually be really useful when you're debugging. I mean, you want to know why whether or not a piece of your code is firing, you can just put a console log in right there in the code and be like, okay, is it getting there? Or is this function I wrote not even working? Who knows? Another one is the document object is the DOM object, right? The data object model of our document. The common method of the document object that we're going to use quite a lot is the get element by ID method, which is it helps you go and get, hey, document object. You know, I know you have a bunch of data objects inside of you, and I know that they all represent different, HTML elements that I built earlier. Can you get me one of them named this? So it really helps you retrieve objects that you might want to do things with in the JavaScript code. All the HTML elements have a wide variety of features. One that we will use quite a bit is the inner HTML element. But that's how you can just change the information inside of different elements on the page. And then the element objects also have style objects. So right, we're getting nested here. We have the HTML element, say, for example, a paragraph. It's going to have the style object inside of it. And then inside of that, there will be all the properties that we can change, like changing the color or the background color, all the CSS stuff we've done. Okay, so we have now covered the fundamentals of JavaScript. JavaScript has a variety of primitive data types. We can use operators to combine and transform that data. We can store that data for later in a variable, which we can also change the contents without disrupting, that label of the variable. We can write our own functions to do lots of instructions all at once. We can interact with objects, which have their own data and instructions in the form of properties and methods. And in the web dev world, it's nice because the objects of most interest to us are HTML objects with their CSS properties, which we've just learned how to edit on the fly. And that, I think, brings us to a circling point of this is why JavaScript is so good. You can learn to do anything as long as you know how to write a logical script. Do anything to your page, right? We've seen how to make the page do weird stuff already, right? You can make objects spin, you can change colors and sizes, you can make things slide into place and slide into shapes, and you could do all of that by editing that stuff on the fly with JavaScript. Okay, some of the tools that you will use, I want to point out here. Your foremost tool is, and your best friend, is the interpreter console. And we've been talking about it already. I want to make clear how to get to it. It's really your best friend for asking, how did I break that? Or what's going on here? Or etc. So to run a single line of JavaScript code, you might just use the interpreter. It's known as the console, right? So console.log, etc. You can type a line of JavaScript, hit enter, and the browser system will just run that code, right? Here on the right-hand side, I've done console.log hello world. Essentially, I'm saying, hey, you, this object I'm typing in, spit out the words hello world. Cool. It does that, and then it actually returns undefined. Interesting. But not huge. Don't focus on that. So to access the JavaScript console, you use the inspector, right? We've been using the inspector to look at the elements of a page. Now we can open the same thing and go to the console tab instead. So instead of using the Elements tab, which is great for all the HTML objects on the page, you can go to the Console tab. One fun thing about this that kind of helps you get into the use of it, you can actually use the console on any page in existence. You can use the inspector anywhere you want. We've already seen that. But you can also screw around with JavaScript. So you can load up any web page in the world, pop open the console, poke around that page's data, and execute code right there. Keep in mind, though, that this is just local. It's like just you messing around on your own web browser. You're not going to change the website, right? That's not how that works at all. In fact, you should know that. We've talked about how web servers work. So really all you're doing is you're mucking around on your local copy of a web page. But it's still interesting. It's still kind of fun to mess around and see what you can manage to do. Because remember, under the hood, you're really just screwing with the DOM object that your own web browser just built, right? You're changing the data of your version. Let's walk through a quick diagram, a guide of how to access this. So here's Google. Here's the homepage, Google. I can pop open the inspector. There's lots of ways to do that. We've talked about it before. Right-clicking the background, going to View Developer. I think Command-Option-I or Control-Shift-I usually does it. And here's the Elements tab. Now let's go over to the Console tab. And in the console, you can do a bunch of stuff. Write hello world, define a variable, define a different variable, add them together, whatever the heck you want to do. This is doing abstract, just console stuff. If I want to go and change, for example, document.body, that's the body object. It's always available right there in the document. Okay, cool. If that's available, I'm going to change document.body.style.background color, which comes across as this RGB functional thing, very similar to the hashtag notation. I'm just going to change it to the word black. What? It did it. I know you already knew that because you already saw it, but you just change it to the word black, and the browser's like, sure, fine. The body is now a black background. Cool. It doesn't have to fight you or anything. It's not like, oh, how dare you change? It doesn't care. It's a dead local copy of Google. It doesn't mind. So, yeah, the interpreter is your best friend, and think of it as the pocket calculator of programming. It's a great thing for debugging. So if something's not quite working, you can sort of jump in and start checking things, check the data, check the information that you've already defined and see if it's going well and alter it. Self-checking for basic things like, okay, I need to I need to write a function that does X. I need to write a piece of code that does this thing to an array. Or, ooh, what was the name of that function I wanted to use again? Just popping right into the interpreter and starting to type these things out gives you tons of feedback. It helps you learn. And then also just tinkering. So maybe your page is working fine, and you just want to try a couple of new things that you'll actually incorporate later. You're allowed to just code it right there for a bit. So if your page is up and running and you've got a couple of things working, and now you say, what else can I do from here? It might give you ideas on what to do in a more stable point. The only thing the interpreter does not do is preserve the code you've been writing, right? So just think of the interpreter as very volatile. If you reload the page, it's all gone forever, and that's fine, right? It's all very temporary. If you actually want to keep functional code somewhere that your page will use on its own, you need a script. Welcome back to JavaScript. Where do we write JavaScript? There are 3 places very similar to CSS. So you have some code you want to run on a page, and you have 3 ways to get it there. One is external JavaScript, so linking to a file with the .js file extension somewhere in the structure. Internal JavaScript, which is very similar to CSS, you can use the script tag and just put code in it, right? You can see here in the middle example, that's the big one, right? And in that one, I've put the script right there, right after, inside the body. It's just the var x, var y, and a bunch of stuff, right? And then inline. So you can actually use any element's event properties, for example, the onClick attribute, to run a snippet of code when something happens on the page, for example, when you click a thing. Okay, let's jump through each of these briefly. I think you've probably, because we covered this in CSS, you should get this, but loading a JavaScript file. JavaScript files are just a series of instructions, very similar to just the series of style declarations before, right? They are executed in order, top to bottom. So to load one of these files into your page, you use a script element, so the script tag, and you define its source attribute, src. So an example of this being this tag, right? Script src equals some file.js. That's the open tag, and then you just close it immediately if you're loading an external file. So note that you can load your own local scripts using the same pathing that we've talked about before, right? Find the route from this file in this HTML file to whatever other file I'm trying to load, right? I'm trying to load the JavaScript. Okay, go find that in the structure somewhere. But another fun thing is that you can also load external packages. You can load code written by other people in other projects to achieve specific things that maybe you don't want to do all on your own, right? This is why the whole open source world is so cool. On the right side here, I have just a simple example, right? If I want to load this JavaScript called test.js, I would use that script element. And just an example of that. So in our labs, I always have those little flowcharts, right? To achieve those flowcharts, to show you what the link structure of your lab should be and all that, I load this external package called Mermaid. I load it from the source that Mermaid, the Mermaid project keeps it at on this unpackage.com, etc. And then I run a really short script to just initialize that. It's I didn't write this myself. I'm not fancy. I just took it from their website, right? I said, hey, how do I do this? And then now, once you've loaded that external JavaScript, anytime that there's a div with the class Mermaid, the script knows how to pull out all the inner HTML and do a bunch of fun stuff with it, right? So this is like, I'm defining a graph, and here are all the nodes. And what it results in is it builds a flowchart. It builds an image of a flowchart, and it just does that on the fly. Super cool. Every time you load one of the labs, that's JavaScript building that right there in front of your eyes. or, well, behind the scenes, right? Okay, got to keep moving. So internal JavaScript is another option here. You can write your scripts right on the page. So if you'd prefer to just write things just here, you don't necessarily want to have a larger scale thing that you need to import into multiple places. You just want to have something right here. You use the same tag, you just don't specify the src attribute. In fact, if you do, it won't run your code. It'll just load the script that you asked it to. So this is a simple thing. It's like saying, oh, var x equals something, log x. All right, cool. It'll dump it right out to the log. This is good for when you're writing code that's meant to function just on a single page, right? Super useful, super simple. Now, where do you place the script tag? It's not a huge deal for us, but it's worth a quick aside on it. Where you put the script is pretty irrelevant for the simple stuff that we're doing, but for completeness, you should have a basic notion of the idea of blocking. So putting the script tag in the head, so up at the top, means that it's going to load first and it will block the rest of your document from loading. So if you're loading a huge script or you're loading from like an outside source like the Mermaid one, this means that your user is going to have to sit there and wait for the script to load to see it, and they're not going to see anything on your page at all. It's not a great user experience. Whereas an opposite case is putting the script tag after everything else in the body lets the page will load first, but then if the page is huge, it might take time for your script to move, etc. So I just want to point out, for our purposes, I'd lean towards at the end of the body section, but it probably won't make a difference. It's just useful to know about the concept of blocking. Okay, so inline JavaScript is the last bit, and this is actually, it's not really, this is important, right? It's not just like an option for doing styles and stuff on the fly. It's actually a pretty important piece of how you make interactivity. So we can use inline JavaScript to have JavaScript called in response to events at the system level. So JavaScript normally fires off as soon as you load it. You load it up and it runs all the code and it just does it all. Just like with HTML and CSS, right? It just does it all immediately. But really, JavaScript is about making our pages interactive, right? They want to have some sort of reactivity to what the user is doing. So we can use the event attributes like onClick. So here's a button. Its onClick is set to the function update. You can tell it's a function because it has the parens. And then we define, the word is clicker, so the button will say the word clicker on it. Note that every element has these same types of events. It's just buttons are nice. They look and feel nice when you use them. You should note that the code that you would use, writing any amount of programming code takes up a good amount of space, right? You're doing a lot of small things on their own lines over and over and over. So rather than try to dump all that into one little inline space, it's really best to define the functions you want to call somewhere in some script, right? Which will happen immediately, right? The script will run and define your function, and then you will call those functions from these event attributes. Over here on the right, we have sort of a reference point for a button that's defined with the update and then the code below. Let's just actually go to the example of this. So this is a video I haven't started yet. Let's look at this. Let's pull it apart. This uses a bunch of the things we've talked about, right? We have the head is empty. We have the body. There's an H1. There's a header 1 up there with here is a bunch of text. And there's a button right below it, labeled clicker, with the function update on its onClick. Then we have a script. Okay, this script, I've got some comments in here. We'll talk about that in a minute. Okay, the first thing we do is we set up a counter variable with the value 0. Again, that's a comment. That's for human eyes, not for the robot. Var count equals 0. Great. Also note that you got to use semicolons when you're working in a script. It will try to figure them out without them, but it's a bad plan to not use them when you're writing a script. Think of them as the punctuation. The next thing we do is we grab that element object that we plan to change. I wrote plant, but whatever. We plan to change the header here. This is going to become a clicker counter. So I grab the element, document.getElementById, the big one, and I put it in the variable element. So now I've got a count piece of information, and an element object. And now I define a function called update. The first thing I do is I update the counter value from count equals count plus, or so this is tricky. I'm going to assign count a new value. What is that value? It's whatever is currently in count plus 1. So currently count would have 0. And then when this calls for the first time, it would be 0 plus 1, assign that to count. The second time it's called, it would be 1 plus 1, assign that to count. Third time, 2 plus 1, assign that to count. Got it? And then once I've changed the data, the count number, the variable of count, I'm going to update the inner HTML of my element, that header, to the value of count. Let's watch it happen in real time. Just kind of, okay, this is not me actively, I did this in the recording of this short video. So I'm just kind of guiding through, right? We see the header and the button, show the script. We got the count variable, we got the element object variable, and then we have what happens when I update. So you click it once, it updates. Again, it updates. It updates, it updates, it updates, it updates. Oh my gosh. Every time you click that, the update function is called, the value in count changes, and then the element's inner HTML is updated. We have made our first worst app. I would hesitate to call it an app, but hey, I can think of things I need to have a clicker counter for. It's a little bit sloppy, but it exists. This is your first app. You can write it yourself right now. Just write out all these words, all these symbols, all these tokens. Okay, I've kept you too long on this one, so let's get to a few tips and notes. These are the simple things. Okay, the things that help us keep everything organized, right? So comments in JavaScript are anything on a line of code that comes after a pair of forward slashes right next to each other. That first one is a comment. This other one, after another line and after the semicolon, you can put a comment there too. It's not always the cleanest, but it's useful for liner notes, right? Quick notes. White space, once again, white space is pretty much ignored. The only thing I want to focus on for you is the semicolon. It's required in JavaScript to make sure the system knows when you're done with a single instruction. As with all web dev, of course, it does try and figure it out. It's trying to be kind to the developers. But for good practice, close your lines with a semicolon, always. Now, another asterisk here, but the interpreter, that doesn't matter as much because the interpreter knows when you're done with writing a line because you'll hit enter and it will just try to evaluate it. Another tip is just keep the interpreter open like all the time. If you're sitting down to write JavaScript code, open an interpreter. It's so useful. It really empowers your coding and your learning to always have the console just like a click away, ready to try things out. It's very easy to get all stopped up and think, I don't know, why isn't this working? What should I do next? I'm afraid I'm going to break it, right? And the answer can very often be found by just messing around in the interpreter for 10 seconds and seeing, okay, does this work? Oh, no, not quite. What does this do? Wait, checking yourself. The worst case scenario is you screw up the page and have to reload it. Or in some cases, if you do weird things like create infinite loops, you might have to shut down the browser and reopen that. But apart from that, you really can't hurt it. Just do your worst to it. There is a tendency for people who are learning programming to get all fearful, like, oh gosh, I don't want to do something that the computer won't like. Like, it doesn't matter. Blow it up. It's great. You will learn so much more by typing the wrong thing into the interpreter and trying to understand the error than you will just like sitting on your hands and saying, oh, I don't really know what I'm doing, So try things. It's great. So writing JavaScript recap. We've just been on a long journey together. JavaScript is a full-fledged programming language, and with that, it comes with the need to understand many fundamentals of any programming language. So what types of data can I use? How do I combine them with operators? How can I store them in a variable later? Combine those ideas into functions. How do I do that? The language also has a major focus on objects, which is actually super nice because HTML and CSS are very friendly to that, at least conceptually. The interpreter is your most handy tool for quick testing, debugging, and trying things out. But really, the true work comes in writing functions in scripts on the page or in their own files that your HTML elements will then use event attributes to call them and ask them to do things for them to create this interactivity. So that is the introduction to JavaScript. JavaScript is your primary method of adding interactivity to your web pages and apps. One of the most in-demand programming languages out there, at least at present. It has major benefits of being like really well grounded in CSS and HTML, and as you continue to learn programming concepts, that those all go together nicely. It has all the features one would expect of any complete programming language, which we're starting to learn right here. And if you pursue learning this language, once you master JavaScript, you're also mastering everything that HTML and CSS have to offer as well. You have full reign over the browser at that point. Okay, thanks for coming along. As always, there's a final thought. Open the interpreter console on a web page. Any page is fine. Try entering some of the lines we used in this lecture. Now try misspelling things, sending poorly constructed instructions, ending lines too soon, using the wrong operator symbols. Really try to mess it up. What happens? Do the errors make any sense to your untrained eyes yet? And if not, was it really so bad to write the wrong thing in the interpreter and just see what happens? Okay, that's it. Thanks. Take care.